Great. So in this recitation, I thought about talking with you about the new subject of decoding, but then I thought to myself that there is no way you're going to listen to something new now that you are in such a pressure in relation to the quiz, right? So I thought about doing this recitation fully, only in relation to the quiz preparation. And maybe after the vacation of Shavuot, we also have a reinforcement and a recitation. So I'll teach it either in the reinforcement, because this is quite an easy subject and we will just tell everyone to come, or I'll teach everything in one recitation alongside with the subject of information theory, and that's it. So okay, so I just wanted to tell you that yeah, I think that's it. So I want to start with a clarification regarding the subject of autocorrelation and cross-correlation. So we were talking about how to normalize, right? And I told you a few times that what you can do, for example, in the duplet example that we have here, the 5 and then 0 to 100. Do you remember this example? And I say that you can just count how many spikes you have within 1 second. And here it's 20 spikes, right? 20 spikes per second. So the rate in this, the rate, the autocorrelation rate for 5 will be 0.5 multiplied by 20. Do you remember that? So when I tell you that, it is something that is common in the literature, that when we look at the autocorrelation, we kind of ask ourselves, what is the firing rate that our neuron, that our spikes meet within each shift, okay? So you take the probability of spikes to meet each other, and then you multiply it by the full rate, okay? But in the exam, we want to be more strict. And we are going to use the mathematical definition given the following. When we have the probability, and we want to go from the probability to normalize it to rate, okay? We don't multiply by the average rate. We take the probability and we normalize it by the size of the bin in the sample rate, okay? So therefore, if my sample rate equals 1,000 pairs, then each bin is 10 to the minus 3 seconds, right? So if the probability is 0.5, then when I divide by 10 to the minus 3, this equals 500 spikes per second, okay? And not 10, as I told you before, okay? Yes. For 100 milliseconds, 500 milliseconds last for the using 1. Why we are using 0 and 0.5 probability if we are asking for 500 milliseconds? I didn't fully understand your question. I'm saying I'm just talking about the normalization from probability to rate. And the way I explained it before is I said, okay, look at the average rate, right? And then multiply the average rate by the probability. So I'm saying it is common in the literature to do so, but in this course, don't do it. You need to do something different. You need to divide by the size of the bin. the quiz? Yes, of course. So I think it was something like that in the quiz, no? So how much was it?
It was 100 milliseconds higher.
Right, so it was 0, 100, and then at 150. Ah, it was given by the Hazard function. Yes, I talked about it before. Okay, oh, it's opening. Okay, so it was in quiz number 4, I think, right? Yes. Okay. Right, so we have this, oh, the next one, sorry. This one, right? Great. So we have the hazard function, and these are really likes this type of question. So I'll show this one and then another one, which is a bit more complicated. Okay. So I have this hazard function, and I have 0.5 for 100 and 1 for 500, right? Okay. So this means that how many ISIs do I have? 2. I can have either the one at 100 or the one at 500. Okay? This is the Hazard function, yes. So just asking what possibilities do I have? Right? So the possibilities are 100 and 500, and the PDF of each one is, oh, great. Is that clear how we move from here to here? Great. So now we are asked, we will do the full autocorrelation. Let's draw the full autocorrelation. And given that firing rate is 1,000 spikes per second, the sample rate is 1,000. What is wrong with me today? 1,000 hertz. Okay, and the autocorrelation should be normalized to rate. And I think I'll just close the. We don't need it because I'll just draw each time. Great. Okay, so how do I start? Yes, Austin.
Draw possible spike frequency.
Yes. Great. This is the best way to start. So we have, let's look at it, and we will have a few possibilities, right? The first one is like this. We have one at 0 and another one at 100. And another one at 600. And then at 700. And another one at 1200 and 1300. Okay? So this is one way, and let's also plot another possibility. What is the other possibility? For example, that I have at 0, 100, 200, 300, 400 and 500. And 500, and then the next one is at 1,000 and at 1,500 and so on, okay? So I have 5 ISIs in a row, and then another 5 ISIs in a row, okay?
It's not six.
So I'm saying 5 ISI, it is true that these are 6 spikes, but the number of ISI is in between, okay? Yeah, it is written here. Given the hazard function, you need to draw the full autocorrelation. Okay, in the quiz you were asked about only the 500, if I remember so. Okay, so let's first solve it for this, and then we will discuss a bit about this one. Okay,
Sorry, why do you have a description?
we have more. I was just giving some possibilities, right? And I need someone to help me after I finish, just to remind me something that I want also, great. Please remind me that I want also to show how to calculate the Fano factor and the city. We'll do it in the end, okay? Great. So let's draw the full autocorrelation. So we know that there are 2 ways to solve autocorrelation, right? The first one is looking, we will focus on this interpretation, is looking at all possible time lags between spikes, right? So what are the possible time lags between spikes? So we have here 100, 500, what else? 600, right? From 0 to 600 and from 100 to 700. Yes. 700, right. Why do we have 700?
From 600.
From 0 to 700. From, right, we have 700, of course, yes. And,
1200 and 1300.
right, but since we're interested only in, let's do it until time lags, the maximum will be 1,000, okay? Are there more possibilities? Okay. Now let's look at the probability of each one. Here, in this case, let's think together. Let's think, for example, at 400. Do we have 400? Where? No. I'm now focusing only on this one. In a minute, I will talk about this possibility. Okay? Now I'm focusing only about this interpretation. Okay, so in the quiz, you write, my interpretation is blah, 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 and then you write this, because this is a possible spectrum given the hazard function. No, you don't have to. Okay, so what is the probability of 100? Why? Given a spike, if it's at 0 or 600 or 1200, there is a full chance that there will be another one within 100 milliseconds, right? But if we are in the second one in the pair, in the 100, there is no possibility that there will be another one within 100 milliseconds, right? So therefore, for only half of the spikes, we have a spike within 100 milliseconds. For 500, it's the same. Okay, for 600. Okay, let's finish. For 500, it's the same because if I'm at 0, no chance there will be one at 500. If I'm at 600, no chance there will be one at 1100. right? But if I'm on 100, there will be one at 600.
Yeah.
So it's in half of the cases, you have a spike within 500 milliseconds.
This question is stuff about outside. Do you look only about the 1,000 or you look farther? Because if you
So-
go 1,000, then it's not half,
Okay,
it's less.
so let's be clear about what does the 1000 mean. It does not mean that you look at the spike trend only until 1000.
Okay.
It means that you look at all the possible shifts, the time lags, until 1000. Is that more clear? Okay. This means that you do count from 700 to 1200.
Okay.
You do count it, although this is outside of your 1000 range. Because the 1000 is what is the maximal width between them. Do you want me to repeat about it in Hebrew now? Okay. ההבדל בין time lag לבין זמן, הוא ש-time lag זה מרחקים אפשריים בין הספרקים.
Okay.
ואז גם המרחק המקסימלי האפשרי הוא 1000. אז פה בין 600 ל-1200 יש לך 600, אבל זה עדיין בתוך הטווח של המרחקים האפשריים. Yes.
So basically, the timelines that we choose are until one point or interval, but then when we look at the probabilities, it's like if the spectrum was infinite.
Exactly. Thank you for the clarification. Yes. Araceli just said that we look at the infinite spectrum. מסתכלים עד אינסוף.
One, it's something like.
Yeah, this is like the kind of things that Ivar likes to add, and they mean nothing. It's something he adds them because he wants to show you that that you can look at the recording as if it is infinite, because it's big enough. And if not, you should count, but he always says like really big numbers.
Even, even if he says only 5 seconds, we should count the probabilities as if it was.
Yes, yes. Only when it becomes really big time lags, then it becomes more noisy. But around 1000, it's still okay. Yeah. Okay. So we have this 100, 500, and now how many spikes do we have with an interval of 600, with a time at 600? What?
One.
1. The probability is 1. Why? Because for every spike, there will be one within 600 milliseconds here, from 0 to 600, from 100 to 700, right? Because in the way that we just arranged it, there is a full chance that there will be another spike within 600 milliseconds, okay? And then for 700, it's again, right? So this is the probability. And now, what is the rate? The autocorrelation of the rate?
Sir, can you repeat from the beginning the probabilities from 100?
Here? Okay, tell me what exactly is unclear.
Why is the probability of half, for instance, for 100?
For 100, because if you have a spike here, you ask yourself, what is the probability that there will be another spike within 100 milliseconds?
Okay.
And there will be one only if you are at the beginning of the pair. And there won't be one if you are at the second one in the pair. Right?
What do you mean?
If you are here in the second spike of the pair, there won't be another spike within 100 milliseconds.
No, I don't get it. What do you mean there's only one spike there?
Okay. There are two ways to calculate the autocorrelation. The first one is by counting all possible intervals, either by the adjacent spikes, or for example, here you have 600 and they are not adjacent, and you count these
Okay.
possible lengths. And another one is by shifting So let's say that you have this 0, 100, 600, 700, 1200, 1300. And then you shift. You shift it for 100 millisecond length. So you have here one and another one here. Here one and another one here, and here one and another one here. In how many spikes
Okay,
does a spike from here meets another one from here?
okay,
And you can see that it's only for half of the spikes.
yeah.
Yes. Yes, yes. When you calculate what the Python does, what the computer does, it's just shifting. Okay? Great. So now when we have all the possible probabilities, now we want to normalize it to rates. So what will be the rate? Yes? Great. So this is the right answer. I know. Yes. So as Aylan said, what I'm doing, I'm taking the probability and I'm dividing it by the size of my beam.
Why are we not dividing by the total amount of spikes?
So I said it at the beginning. It's okay to repeat it. I really want to repeat it. It is true that in most of the literature, they multiply it by the number of spikes in 1 second, okay? As I did, I told you that you need to multiply this half by 3 because you have 3 spikes per second, right? So this is a common way in the literature, but in the course, you need to divide it by the size of the beam. Okay? I'll explain in a minute why. I'll show you an example. So you need to divide our beam equals to 10 to the minus 3 seconds. Therefore, when I normalize from probability to rate, I divide by 1 over 1000, therefore I multiply by 1000, and from half it goes to 500. Okay? Is that clear? It's a very, very important clarification. Okay? And I want to show you in a minute what does it stands for. Okay? Yes.
I understand that we have to divide the probability by the size of the beam, but then we said something on multiplication that I
When you divide by, if you have a number and you divide by 10 to the minus 3, this is like dividing by 1 over 1000, right? And this is like multiplying by 1000.
yes. I didn't like concentrate 1000.
Right.
So why
I'm multiplying by the rate. Okay? It's like dividing by
divided by the rate or
multiplying by the rate or dividing by the size of the beam.
she just like
It's the
why
same.
it's 10 in the power minus 3 and not
This is the size of each beam in the recording
in seconds?
in seconds. Is it more clear?
The
Yes.
size of the beam is always 1 divided by the center rate.
Yes. So therefore, if you divide by it, it's like multiplying by the second rate. Yes.
I think this is how we learned to do it in the last master enforcement when we were in the other room. But then
Right.
the quiz it just changed the answer.
Yeah. It's my mistake. And it's not like really that I did a mistake and I told you something which is not true, because in the literature, this is how you do it. You ask yourself, what is the rate that the spike meets? Okay, because the rate, when I show you this sheet, the rate that the spikes meet is that they meet 1 every 100 milliseconds. Therefore, it's 10. Okay, as I said in the reinforcement. But I talked with Izar, and I want to show you why do we use this definition. It is related to the Poisson model. Okay, So why do we divide by the size of the beam? Let's say that we have a Poisson neuron with a firing rate.
So here the answer would be 500, right?
Yes. So we have a Poisson neuron with a firing rate of 50. Okay? Yes. This means that the probability for a spike in 1 millisecond is, if I have 50, on average, 50 spikes every second, then the probability of a spike over 1 millisecond is 1 over 50. Is that clear? Right? And this equals to 0.02. Now, if you go the way that I explained it, so you say, if I want, this is the probability, and now I want to go to the rate. So what I said is take this. No, this is not true. What I just read.
50 over 1,000?
Yes, exactly.
So it's 0.05.
It's 50 over 1,000. Exactly. I knew that something is not right here, but otherwise it works. 0.05. Is that clear? Why? Great. Because I have 50 spikes per second and I have 1,000 milliseconds. So the probability of a spike within 1 millisecond is 0.05. Right? Okay. So if we are doing it the way that I offer it, so I'll slide here. This is Yarden. Okay? So what we need to do is 0.05 multiplied by 50, and this one equals because this is how I operated. I said, take the firing rate, the average, and multiply it by the probability. This is what I told you that you need to do. And then when you multiply it, what do you get? 2.5 spikes per second, right? And this is not the right way to do it, because what we want to get is to go back from the probability to 50, right? So if I want to go from this probability back to 50, I need to multiply it by the sampling rate. Therefore, by 1,000. Okay? So what does the firing rate stands for? It says if it was a Poisson neuron, then this was its firing rate. This is what it means. It's not really the firing rate that each spike meets when there is this shift. Okay? It's what would be the firing rate of a Poisson neuron if it was a Poisson. Okay? So the autocorrelation in such case would look like this. So over here we have I'm going back to this example. So we have at 100, 500, 600, and 700. And it's 500, 500, 1,000, 500. Okay? And here you have zeros. You have zeros in between because you don't have any time like 200, 300, and so on. This is the autocorrelation. Yes. Yes.
But from the graph,
It will be so huge, but then you will have so many zeros around. So you might say that in a way, it's kind of average. It is true that the better you, that the higher your sampling rate, then this height will be higher. For example, if I use 10,000 hertz, then this will be 10,000 and 50,000. Oh, yeah, 5,000. Right? It is like this. Yeah, the firing rate does not mean firing rate number of spikes in 1 second here. Okay? I know, very confusing. For this reason, in many of the studies, it is not used by this definition, and it is used like I know it, but for the quiz, solve it like this. We know the problem. Yes.
There's a third way that we want auto-correlation, which is the one in the email that you sent. Where we had a neuron that was excited by another neuron and it changed its rate. So we had this neuron that went from 10 to 10 to 10. And we did it times 1,000 is the sampling rate divided by 5.6, which was the total amount of spikes that we expected to see.
Right.
And do we still use that method for some cases?
No.
Never. So
For the quiz done in your paper, you are most welcome.
we just forget the
Again, you need just to divide by the size of the beam from probability. In the email, there was an example, if you remember the oscillatory one. And over there, I did divide by the size of the beam. If you remember that. I will show in a second another one. Okay? Yes. Yes. Thank you. Okay. So, what?
So we have like given probability.
Yes.
Second matches itself.
Yes, of course. Why? Because you have the 5 ISIs in a row, and then you have another 5 ISIs, the bigger one in a row. Maybe I'll plot something more clear.
Ah, okay, so it would be 10.
So I'll just do it again. Okay. So another way to interpret the hazard function is saying that we have here a 0, 100, 200, 300, 400, 500, and then 1,000, 1,500, 2,000, 2,500, and 1, 2, 3, 4, 3,000. Okay?
Now we will do everything for the other one.
Yes, for this way, I'm just showing
It's not
another
gonna be
way
the
to
same?
interpret. You don't have, no. You don't have to solve in the 2 ways. I just want to show you that in the exam, of course, you will write the way that you think it should be interpretable. And in a minute, we will see why, for example, when we calculate the Fanon factor or the CV, it is easier to use this. And when you calculate the autocorrelation, it is easier to use it. Okay? Yes.
When you're talking about two different methods, you're talking about, you need the spike interval to be like 100, 500, 100, 500, 100. And for the second method, it needs to be like in a row.
Exactly.
Okay.
Yeah. All the 100 in a row.
And again, all the 500 in a row. And does it matter like the numbers of spike interval in which you do it? Like, I mean, does it have to be like 5 100 millisecond interval in a row?
No, it could be also 10, for example, and then 10 like this. It's still the same hazard function. Yeah. More question? Okay. So let's see what are the possible legs that we have that are smaller than 1,000. Yes. So we have 100. In how many of the cases? great. In how many of the cases I have 200? So I have from here to here, from here to here, from here to here, from here to here, 4 times. And all the possible ISIs, I have 10 possible ISIs. Therefore, it's 4 over 10 possibilities. So it's 0.4. We'll do here 0.5, 0.4. Is that clear? Again, for 200, I need to have between 0 and 200, 100 to 300, 200 to 400, 300 to 500. From 400, I would not have one at 600, right? So I need to skip one at the more narrow, more, yeah, is it right to say narrow? Because it's more, how do you call it? That it's dense. Yes, great. In the more dense area. So I have only 4 like this out of 10 possible ISIs or 10 possible, yeah, 10 possible time lapse. So I think it's 0.4.
Right.
So maybe I counted wrong.
No, you have 10.
I have 10, right? I have here 5 out of 10 spikes.
But it's supposed to be.
Yes, I need to divide it by the number of spikes.
But it's supposed to be not, but what about first spike? 0 times?
Excuse me again?
The first spike
Yes.
in the 0 times,
Oh, you count only the one from here to here.
11 spikes, but then I was.
Yes, exactly.
No, but you said we only need smaller than this number, so one is.
Smaller than what number? Smaller than 1,000.
So why you're
We're
going
doing-
all over the.
No, this is the possible time lapse. This is a different 1,000. This is not the time. It's not that I stop here.
Why don't we count the first time?
Because then you have just, it really doesn't matter if you count it or not, to say the truth.
Change it better.
Yeah, but it's okay. It still goes one lower, it's a minor change. Yes,
What are we supposed to think of the spike transit?
yes. So then you look at this cycle
Yes.
and you just calculate from one cycle and then you say, I saw the pattern, the probabilistic pattern, and I solve it for the infinite spike trend.
By cycle, you mean the amount that accomplishes 50/50.
Yes.
Right, like 5 and 5.
So you will have another cycle like this and then again like this. So it is okay just to say I look only at one cycle. Yes.
Should we divide by the number of spikes or
By the number of spikes.
it would be 11?
You can either write here 10 or 11. 10 means that you say at 3,000 there is a new cycle. So I just look from 3,000 towards. Or you can say I look from 1 to 3,000 as one cycle. Did I answer? Here at 3,000 there will be another one at 31, 32, 33, right? So you can say, I look at this as a cycle because I don't want each time to count the first one from the next cycle. Or you can say, I look from 1 to here. It doesn't matter, you take 1 off. I think you are very, very confused, okay? So would you like to play a game where I draw my board pencil whatsoever, and the last one to stand on one leg, okay, and touch the nose. We need to bring.
But all of us are really listening. We want to.
Yes.
Yeah, we're not really.
Okay, Yeah, it is true. So, do you feel like, okay, so I really want to focus you back in. So I think the right thing that we will do, instead of stopping to the question each time, I will have here a possible number of questions. I will write the number of questions until I finish, and then when you finish it, you just have to wait until the end. Okay? What do you think about that? So you have 3 questions left. From now until the end of this exercise. So you really have to think if you need to ask it now or to wait until the end of the explanation, okay? For all of the class together. For all of the class together. Or if you really have to ask the question in the middle of the explanation, you need to bring the chocolate for everyone for the quiz. No, I want you to wait with your question until the end of the explanation. So if only if you have a very urgent one, you can use one of the 3 over here. And if after we finish the 3, you really have to ask, you will have to bring the chocolate for everyone for the quiz. So if you feel like bringing chocolate, you can ask as many questions as you wish. Okay. So now I want to show the calculation for 300. So in 300, I need to have a spike between 0 and 300, 100 and 400, 200 and 500, right? So I have 3 possibilities again out of 10. So this 0.3, and we can understand that for that for 400, it will be 0.4, and now we reach the 500. So let's see. We have also one between 0 to 500, but then we have 5 more that the ISI is exactly 500. So in this one, I need to have 0.1 plus 0.5, and this equals 0.6. Okay? It's 0.2. You just lost. You could wait. You could have waited until the end.
Ask any question instead.
Yeah, but it's still confusing for those who are still not fully sure. So even in this case, it's best to wait until the end. Okay. So 0.6, and then the next time lapse will be at 600, right? So how many do I have at 600? I have from 100 to what? I don't have 600. From the 400. Sorry, right. From here to here, right? I have only one like this. So it's 1 out of 10, and this one equals 0.1. And for 700, it will be also 1 over 10, so it's 0.1. 800, 0.1. 900, 0.1, and at 1,000, I will have exactly as the one in the 500, right? Because I have from 0 to 1,500 to 1,500, from here to here, it's 6 times over 10, so this is 0.6. I finished the first part of the explanation. You can ask questions without reducing the effort. Yes.
Can we go over the PowerPoint?
Yes. More questions? Yes.
Why is it 6 for 1,000?
6, because we have 1, 2, 3, 4, 5. So it's 5. Like the fact that we have from here to no. Not necessarily. No, you do. You're right. Because there is another one over here. Yeah. This is why I say you don't need to solve it like this. This is much harder. Yeah. So it's 6.
Why 6?
From 2,500 to 3,500. Now, regarding your question, Araceli, when we do the 500,
But then you start another Like cycle, why don't we have?
Right, but there will always be one from this cycle meeting the one from the
No,
other
it's
cycle.
It's okay, but then the 100 will be 0.6, not that. Because you added.
No, because this one I don't count it in the cycle, yes.
Then we also have to add one for 600, right?
For 600, why 600? It's always from this to this, right?
No, from 2,500.
Ah, right, you are right,
I thought that that was much.
yes, yes. Right. Because I need to count from this to the first one here and so on. Yeah, you're right, I didn't think about this possibility, yes.
So we say the maximum time like is 1 time, right? Really, kind of like the.
Yes.
So we always include 1 time. in
Yes,
our-
yes, this is the maximum. Yeah, so about the 500, is it more clear now that we did, okay. Right, so for the 500, I count 0 to 500, right? Because I can also count this one. And then the other one is from 500 to 1,000, 1,000 to 1,500. So I have 1, 2, 3, 4, 5, 6.
So we don't have.
Yes, yes. Okay,
So we add another cycle when there is a moment in our interval that we need. another
Yes.
cycle.
yes. And this is much harder, you see that also I confuse, and it's much more confusing to do it like this. And you see that the autocorrelation is much harder this way, right? And then you need to multiply it by 1,000 because you need to do it in the pairing. So I'll keep here the probability. So in the probability you have at 100, 200, 300, 400, 500, 600, 700, 8, 9, 10. Okay, sorry that I don't have a lot of space now. So in the 100, it's 0.5. And then 200, it's 0.4, 0.3, 0.2. And then it's 0.6. And again, 0.2, 0.2, 0.2, and 0.2 and 0.6. Okay. So if I would given the chance to solve it, I probably wouldn't try to interpret to take the possible interpretation of the Hazard function like this. Okay, so I don't know if you see in this course that I don't really want to show you that I cannot do any mistake. I do, it's okay, but this is not about what we do here. We try to explain the principle, the mathematical principle. So it really doesn't matter if you wrote here 0.1 or 0.2, because in real life you would just compute it, right? But the reason that we are showing this is that we want you to think about what you're doing in your computation. So I can tell you that very low chance for reduction of points if you written here 0.1 or 0.5 or something like that. Just really. I think you already began to see that they are very fun. Okay? Okay, now I want to show you. Yeah, I opened. Yeah, the CV and the Fano factor. So in the CV, we look at the possible I size, right? The thing is that with the Fano factor, we look at the spike count, okay? And then the Fano factor is, remember, it's the variance over the expectation, right? So the easiest way to compute the variance is that the variance is 0. In each one of these two possibilities, the variance is 0.
Yeah.
Here, the variance of the 100. It's in the first one? Wait a minute. No, it's not, right? The variance over here, let's compute it. The expectation of the ISI of the we need to count until 1,000 here in the sum of factor. How many spikes do I have until 1,000? I have 4. Right? No, it should be 3.
Why? There is one. Why not do?
1. I need to count from, no, it's okay, it's 4. Yes, it's 4. Okay? So the expectation is 4.
1 at 0.
And what?
The 1 at 0 is counting.
And again, you say that it's the same all the time for the 4. So why did I even remember that the easiest way is to do it like this? When I take the 500, right? Exactly. Also for the 500, right? No, so, yeah, you're right. Yeah. Sorry. So I probably got, I thought about something else. Yes. So, anyhow, also for the Fanon factor, the easiest way to calculate it is that you have this kind of interleaved intervals where you have at each 1 second, you have 4 spikes. And then the variability is 0, and you don't need to compute anything in such case. Okay? So I think for all the reasons, the best way to interpret the possible Hadard function and the easiest way to compute it is by this one. And not by the also for the autocorrelation and also for the CV. Yes.
The site at 0 counts, right?
In the Fanon factor, yeah, I was just wondering about it, that for example, if I take from 300, no, let's take a window that does not overlap with the one here. So if we take a window from 400 to 1400, then you have 4 spikes, right? So you can say also about the 1000. So in the 1000, you have the problem if you take the 0 or not. So 1000 window is from 0 to 999. Okay? And then you have 4. Yes.
So if we were to compute the variance in the second one, it would be different in the.
Yeah. So here you have 5 spikes, and here you have only 2, each time. Okay. So now I want to show you another hard question from Hagar to autocorrelation. I don't believe that we just spent an hour about that. I'm sorry. But I hope that it helped you. Here?
No, for autocorrelation, like if they wrote on a quiz that something has a probability of 0.52 times 5 and the other one 0.2.
Oh, like the one that you talked with me?
Yeah.
Yeah.
I don't know how to
Approach it, yes.
approach the question like this.
So-
And I didn't find anything that like this.
So let's do, I'll have another example that I think is it really looks similar to the, it's another kind of question that Isa really likes. So very high probability. And then it is also about how to calculate the probability. Okay, and it's this question. We'll go back to it in a minute.
About the recipe with
Yeah, it's this one here. Thanks. So let's look at another example. You have this hazard function like this. And you're asked to sketch the autocorrelation function plus minus 1 second and explain your computation. And then you need to answer the question, is the neuron Poisson, regular, or bursty? Okay, so in this kind of question, the problem is that it's not a simple hazard function, right? Because it's not like the one that we had here, that you have an ISI either at 100 or at 500. Here, you could add also a spike here, and no spikes here, and then there are these higher probabilities over here. So how would you approach such a question? No, here it's really time. Here it's the hazard function. Given that there was no spike until now, what is the probability to have a spike now? Benji just told me that I need to stop talking about buses with you, and I need to say, given that there was no war in the past 10 years, what is the probability for a war in this year? And I said that this is quite triggering. Yes. Okay. Yes, up again the line. Yes. Okay, so it's a Bayesian function. Therefore, unlike the PDF or the CDF, it doesn't have to sum up one, because you divide between two probabilities. So the output of the division, the result might not be one. It should be, sometimes it's even bigger than one. Yeah, because here you have only two ASIs.
Okay, so that's the.
Yeah, this is the reason. Okay, so yeah, I'm saying.
How can we ensure that this works? Because the way we remember hazard is any size or the flying rods to this time.
So this, the hazard again represent, if I waited, I missed the bus here. And then I waited for 40 seconds or 40 minutes. What is the probability that there will be a bus now?
So it's time lag.
No, time lag is possible intervals between.
No, I mean
Five. Yeah, it's only ISIs.
So this is
Only ISIs. Yeah. Okay, so how to solve it? So when we look at the hazard function, we need to check what are the different parts that we see. First of all of you just saw here the straight line. What does a straight line in the hazard function represent? Poisson neuron. With what kind of a firing rate? 50, right. Why?
Because it's 0.05 multiplied by 1.
Great, exactly. Okay, 0.05 multiplied by 1,000. Okay, which is the number of milliseconds in 1 second. And then we can see another period over here, which represents. Exactly. So there is no probability for a spike over here. Let's say that we can approximately say until 10 milliseconds, no probability. Okay, this is the interpolation over here. But let's say no possibility to have a spike over here. And then we have these two, as said Omi, burst, right? There is a higher probability for a spike over here and over here. At what rates? . here at, I remind you, 0.05 multiplied by 1000. So here it's 0.18 multiplied by 1000, therefore 180, right? Fine, great. And here, let's say 150. Okay? So
Is it spikes per second or?
it's spikes per second. So here you can see that we have all the following. We have the 50 spikes per second, right? So for the straight line, we see few changes. We see in the first 10 milliseconds, there's a refractory period with lower probability for spike. After we notice these two horns representing elevation of the probability, bursting, okay, and another one at 42. See? Here, the time here is at 10 and here it's at 42, right? So now we need to think what possible time lags do we have? Okay? So we know that basically the autocorrelation rate should be, if it was a Poisson error, it would look the same as the hazard, as a flat one. But now we need to take these 3 periods and put them inside the autocorrelation. Okay? So let's start with the refractory period. So the refractory period says that at the time lag from 0 to 10, there will be no spikes, therefore no possible time lags. Okay? And then we need to see what happens for the two horns, the one at 10 and the other one at 42. Okay, so we will have bursting activity both in this one and also in the linear sum of them. Do you understand why? Because I can have also at 20, 30, 40, right? And also another one at 42, 80, 84, 106, and so on. And also all the combinations. 52 is 42 plus 10. 62 is 42 plus 20. Okay? 72 is 42 plus 30. And 92 is 52 plus 40. Okay? All the possible combinations. Okay? So I have now a list of all the possible combinations. And what I can say that in this list, in the possible combination, they won't achieve the same height, right? Because the probability of 20 is the probability of 10 squared. Is it clear why?
Yeah, but wait, don't
Two.
you also need to like consider the linear of 42 times 10? Like 94 and 127.
127. Yes. Yes, also. So I need all the linear combinations. It's good. Until 1000. Okay, so why is it squared over here? Because the probability, let's go back to the hazard. The probability for 20 is that we have a spike here and another spike 10 milliseconds after. So it's the probability, same probability squared. You understand? It has to be one after the other, and they are independent, so we need to multiply. So it's this probability and again another one within 10 milliseconds.
So are we still following the logic that we say if there was no boss at this time, what is the probability of the boss will come at the?
Yes.
But in the first, I remember one of the questions in a quiz, the probability of the boss coming at let's say 100 was 0.5. And then a flight coming at 1. So that is not squared, that is the sum of 0.5
here it's in the, you are talking about the hazard function.
Yes, like
The
that.
buses are for the hazard. In the autocorrelation, it's not the buses, it's the intervals, the possible intervals. So what I'm saying that if I have this neuron here, okay, and there was a spike here at 0. So the probability here, right, to have one within 10 milliseconds is, I don't really want to calculate it, but, no, I can calculate it. It's 0.18, right? And then the probability for another one over here, it's again 0.18. So the probability to have this possible time lag from here to here is 0.18 double multiplied by 0.18.
Probably I'm just confusing myself with hazard relation, but why at 20 when we have that probability we see a flat line? Like in 20?
Yes,
In 10 we have 0.18, right?
right. This is the PDF, yes. Here it's exactly the PDF.
In
Yes.
20 milliseconds, it's not 0.18.
Oh, so you're saying that we need to add this, right?
No, I just don't get why do we have 0.18 there? At 20
The
milliseconds.
0.18 is in relation to this one, and here in relation to this one. So what I'm trying to explain is what is the contribution of this bursting, okay, to the autocorrelation. And the contribution is that there is a higher chance to have a 20, higher than the probability here. Why? Because you would have also this probability and also the probability again and again of things. Is that fair? So it will be higher, but not as high as the one here at 10.
But it's smaller, right?
Yes, it's smaller. So you need to have this. And also, as Araceli said, you have the one here at 0 and 0.05 at 20. So you need to have this multiplied, right? Because this is this timeline, and also add this one.
Because it's only time lapse, we are. Okay.
Exactly. Okay. So I just want to show you the autocorrelation. So I wish to send Benji for simulating, but you can see here exactly this idea that at 10, I have this bursting, right? And there is another one at 42. And here at 20, I have another burst, not as high as this one, smaller, but this one consists both from the probability of this one and the probability of this one, okay? And in this type of question, we don't even ask you, commonly, we don't ask you to plot, to sketch the full y-axis. We tell you, note some specific probabilities that are relevant. So for example, over here, you need to specify that this is 0.05, right? And here it should be 0.18. I know this is not what's written here, but this is what I would expect. And then you need just to plot this, and this could have different sizes, but these are combination between all the possible probabilities. Okay? Yes.
Peak at 40, similar to what we see in the hazard, why is it so much smaller?
Here?
Yeah.
It should be in the 42.
Okay, but still, I mean, in the hazard function, it's almost as high as the stimulus.
In the 40,
It's
it's,
0.5.
yeah,
And that population is very low.
here it's exactly at this 0.05.
Yeah, I mean, at 42, it's 0.15.
It's 42, yes, and then you have this
Look at the
version.
population, it's not, right? It's like.
No, it's lower, right. here, this one. So anyway, it should be shifted a bit higher. It should be around 0.05, right? And this one at 42 should consist. Oh, so you say that this, you would expect that this would be, right? Yeah, because there is a higher chance that already there was a spike here and then there was this refractory period. So if you need to get here, you need all of these spikes before not to happen. So it's a lower PDF, right? This does not represent the PDF of 42. It's the average. It's the PDF divided by the survival. So here, okay, here lower, here is the data not for 100 seconds. Simulated a bit shorter, so this is a bit lower, only because of that. But it should be here the peak at 0.18, and then here at the 42 lower, and in between you have also peaks which are becoming lower and lower. Okay, like how do you call it in waves? Do you remember the word from wave theory? Do you know what I'm talking about?
Yeah, it's like muffled.
No. Disperse, yes. So they disperse, right? Like the waves of the sea, that they become lower. So this is what you see here, since the probabilities are now multiplied one by each other, so these peaks are dispersed. Okay? 1 minute, Araceli. Chill.
At the beginning, when you wanted to go to the rate, you multiply by the 1,000.
Yes.
Because it's the sampling rate.
Yes.
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 So if the sampling rate was 3,000.
Yes. Unfortunately, yes. Yes.
But just to make sure to know what to plot on the y-axis. For example, if you have 30, like if I want to know what to plot corresponding to the 30,
Yes.
I would do 0.18 to the second, right? Plus 0.05.
0.05 plus 0.18 squared.
Yes, squared, and then I would add the
Yeah.
baseline.
I
Right?
think, yes.
And then for the 40, the second verse, like following up on what Austin said, is it because we took the value of the 100 and subtract from 0.18 to the third?
Yeah.
Elevated to the third?
So in the hazard, you need to, okay, what is the difference? Why here? From the hazard function, I fully understand that the PDF of 10 milliseconds is 0.18. Why? Because there was no spike here. Therefore, in the hazard function, the small value beginning represents the PDF, right? Because it's PDF of the ISI divided by 1 minus the CDF of the ISI at T minus epsilon, right? The ISI minus epsilon. The one before. So here, since I know that over here is the refractory period, so I have only spike over here. So this equals to the PDF because it's before the CDF was 0. But here, this represents something else. Right? Because there was already some probabilities over here. So now the PDF is divided by something.
I don't really know how to plot it in the
So for example, in the autocorrelation, you don't need to write the value of this.
Okay. It's more just a shape.
Yeah, just the shape.
Okay.
You just give the shape of the dispersion of this peak at 20, 30, at 40, you don't even see it in the simulation. And then there is another peak at 42, N of 62, N of 62, and so on, and this is person. Yes,
Is it the full relation function? Or just part of it?
this is
Because
until 100 milliseconds.
the your correction function is supposed to be like symmetric, right? Because
Yeah.
You take the signal and then you shift it from the beginning to the end, so how
Yeah.
come this is
So this is only the positive part. Since autocorrelation is symmetric, it is
okay,
commonly
so
not plotted for
Okay.
the two sides, you just
Okay.
plot it for one.
So- this is just the positive side?
Yes. Yes.
So, yeah.
I'm thinking about how to construct the PDF. Right, so I see. I'm wondering why Benji did it so that it's 0.14, because it should have been 0.18. So maybe we did do here, I'm thinking that Benji simulated that there is not a full refractory period, but like the one that he did, that it's a linear refractory period. And then he got this. And so for this reason, this is not a 0.18. Okay? I think this is what he did. And here at 42, he added. I'm thinking if you can do it not heuristically, can you really calculate here? Here it goes exponentially. Continuing. I just give the few possible here for this 42. And then I see what is the one that brings this second bar to the horn to the height that I want. I'm thinking if you can do it, just calculate it directly. Because if you want to calculate it directly, we need to calculate the survival. Right? I don't think you can do it directly.
Another question?
Yes.
What causes the decrease in after the first peak? I mean, there's a decrease not only below 0.05, but also like there's a decrease between the what looks like the average of the signal. I mean, later on.
Yes, this looks like much smaller. Think about it in the autocorrelation. So if I want to be at 0.05, I wouldn't expect that. By the way, I just must say, this is a good question because Ali is really looking into details. This is not something that is expected from you to plot or to sketch, okay? The next thing that you need to sketch is this, and the fact that there is a flat line with this dispersed waves, and here it's 0, okay? But I try to think together, why should there be such a decrease? Yeah, but still.
See the other in the other relation, you see the refractory only on the lag.
Exactly. You see it only before the bursting, right?
There was a spike.
Ah, so you have now a lot. Exactly, right. So exactly, since you have a lot of spikes here, there's a refractory period. So you need to wait after this one. If you want to have here something, it should be that there was no spike here at
Okay.
10, and then it's a question mark. And I think this is the reason. Because most spikes, they are kind of they are not attractive, but they converge towards this periodic version. More spikes will probably be here. There is a higher probability, therefore a lower probability for
Like the horns and the.
exactly. And I think this is also probably the reason why it fluctuates around this 0.5. Cool. Great. Again, this is not one of the things that you would be reduced by points because there is some level of computation that is not expected from you. You just really, when you solve it, the main thing that you get points for is your explanation, okay? It's not the sketch. So if you show that this is a Poisson neuron with these two variables and a refractory period, now you need to explain how you understood it and what you need to do with this data when you compute the autocorrelation. So there are some things, for example, the fact that it goes lower than the 0.05, this is one of the things that I don't think it is very plain to think about it. This linear combination of the refractory period and the burst. Okay? Well, we had really a lot of time. So at Sunday, I really want to solve with you together this question. So I want to ask you by Sunday to go through the recitation notes, okay? And maybe what we will do is that I'll ask Sophie just to open another presentation that we will use this presentation during the class, okay? So I mean, like, we will have a class at Sunday, which is a reinforcement towards your quiz, okay? And in this reinforcement, we will have 40 minutes to go through questions about the notes here, and also the mathematics. I sent you some of them. There is some overlap between this and the one that I sent you in the mail. Okay, so just go through the exercises and the solutions that I sent you, and note the correction that I just told you about. Go through it. In the presentation, add your questions. And add questions about exercises that I did not give you a solution that you try to solve alone. And then I really want to do this one before your quiz. So please understand it before, because we won't have time to go into so much details as we did today. Okay?
Can you speak about the size of what you for reception hours?
Yes.
Okay, so then just say.
Yes. Great. Great. So the same link and just copy it in the group, and let me know if you need reception hour. On Sunday, I cannot have 2 hours of reception hour, which is a kind of another class and then another reinforcement and so on. So on Sunday, if you wish to come personally to ask me a question for 10 minutes, something like that, 15, it's also okay. Just come to my room 213, or you can schedule a Zoom meeting and we can do something personally face-to-face, okay? But otherwise, wait for the reinforcement, and in the reinforcement, we will do things that you think we can all learn from them together. Okay? You look so tired. Was it that confusing? That hard? Okay. I think, autocorrelation is a very tough subject, but it's kind of, in a minute it will be behind you. So just. Yeah, so this question over here is also for autocorrelation and cross-correlation. And this is a very good one. And one of the kind of results really likes that you have this 100, 200, like it's a kind of a composition between this and the Poisson neuron. So this is just about the kind of desire. So go through it deeply together in pairs. And on Sunday, we'll talk about this exercise. כן, בטח. העליתי את זה לאתר. Okay, where are the notes? There is one on the website, it's called Recitation 5. And I also sent you some additional exercises by mail. Some of them are overlapped because some of them are really like this one, so I think it's also in the match and with the. של נר ראשון במהלך שעת הקפה. אז מה תעדכנו? יום ראשון תחליפו עוד שעה בין 12 ל-2.
רגע, יש שתי
בתחילת שבוע הבא. לא, הבוחן הבא יכלול גם את הנושא של דיקורינג וגם את אינפורמנט. כל אלה מיליונים שניות, יש לנו 4 ספייקים. אז סופרת כמה ספייקים. פה יש לנו 4, פה יש לנו 4, פה יש לנו 4. אז השונות בין חוויות הספייקים לכל זה.
That's a question where it's, there was last slide was given with normal distribution where the mean is like 100 and the test is like 5 minutes and we don't I was asked to calculate exactly
Right.
And my question is, if you like FCD so the common factor should be 0 because there's no variance between the spikes. I mean, I was just giving the distribution of the ISI.
Yes. This is the distribution of the IC. So the CV is just
CV is that
5 by 100. I think there is a solution to this question here.
was like the 05 exam.
Yes, yes. I know, and there is also a solution for this one here. No, not this one. It's in recitation 2 that you take, for example, a window.
Yeah, but if the FTD of the ISI is constant, doesn't it mean that there's no, I mean, if I take a 5 in, then the 500 is the same. FTD of the ISI
The variance is 0 if there is a regularity. So I think it's not.
So how do I calculate
So
after given only the normal distribution of the ISI?
So, I think it's this one, right? It's a CV or no? It's recitation 2. Okay. Here. Yeah, so this is what I remember, that you take the time, right?
But I don't know what time to take. I only know that the mean is the mean of the
Right, so you have 2/3 of the ISIs are between 90 and 110. So we
Because
can
this is
evaluate that the
sensitive.
STD of spike counts over T are given by. So you can just use this. This is how we do it.
okay. And then the final factor is
Yes.
given that it is just it is the same.
Yes.
Okay.
So you can look at it, it's in the recitation to notes. So
Okay.
I remember that you kind of take the one STD and then you use it as an upper limit.
Oh, okay, you do the upper and then.
Yeah.
And then.
Yes, exactly.
Okay.
Yeah, the difference was a lot. The deviation is 4.5.
Here, so this is
So here, the difference is,
here. Here it's 1 for the maximum spikes over 100 milliseconds. And it's 0 for the minimum, right?
But it's not 0.
Almost 0.
No, it's almost 1.
It's almost right.
Just as close to this to 1 is.
Exactly, right. So it should be, but it's the same. So you write here 1 and then it's 0.5 squared. Anyhow, right?
Wait, but if it's if this one is 1,
So this one still sums up to 0.5 squared.
yeah, yeah.
Then it's 0.5 squared.
but then in the, no, it's somewhat regular.
Yeah,
It's a little regular.
Yeah, you look at the regular as a kind of maximum value. For variance.
But here, the difference between 10 and 11 is 1, right?
Right, so you calculate the variance because the variance, let's see, the variance is the probability of the value minus the expectation.
Yeah, but this is
So-
a factor.
Yeah, also the variance is the same here. You need to calculate the variance, right? So this is the mean. So you do 0.5 0.5 multiplied by 11 minus 10. The variance is like this. 0.5 multiplied by 11 minus 5 squared gives 0.5 multiplied by 10 minus 10 and a half squared. Then this one equals to 0.5. Okay.
So what do you think about the regularity?
So-
What it is from
Yeah. So if so Olin says if you have this neuron over here and the STD is always the same, does that mean that this neuron is regular? So the variability is 0. So I said no, this is not how we calculate it. We look at we make instead of looking at the Gaussian, we look at the uniform distribution between the one STD here and one STD here, which is almost 2/3 of the samples. And then this is our upper limit for the variance.
Okay.
And I have another question. That
Yeah, but
confuse
the proof
everyone.
is, can we use some of the questions at Sunday? Is that possible? Or you can write me an email?
Yeah.
Because I really have to go. Are there any questions which are really, really urgent?
Do we have?
אבל את צריכה להביא שוקולד עם הפעם הבאה.
אז תסתכלי. So there is the question here at recitation 3. It's about the same.
No,
A probability of P given these times and 0 at other times. It's the same. ואז את רואה, יש פה בדיוק את העניין הזה, שזה
רגע, תגידי אם זה אותו דבר, ואז אני באמת אעבור את זה, כי כשקראתי זה הרגיש לי לא אותו דבר בכלל.
אוקיי.
אז אני לא יודעת אם הבעיה אצלי. אבל נגיד פה רשום, כאילו נגיד שאחרי ש-A ירה, אז יש סיכוי ש-B ירה ב-0.5 וש-C ירה ב-0.2.
כן.
כאילו מבחינת ההסתברות. ואז אני חושבת להם קרוס קורלציה. אני לא יודעת איך לגשת לזה.
נו, אבל זה רגולרי, כל 100 מילישניות.
נו.
ואז זה, אז תסמצי.
איך אני מחשבת קרוס קורלציה שיש לי הסתברות של...
תציירי קודם, דבר ראשון, את הספייק טיים. בסדר?
אבל יש מיליון אופציות לזה.
למה?
כי
לא,
או שהוא
זה-
יורה או שהוא לא יורה.
אז תעשי, ברמה העקרונית, למה זה משנה? אם היה לך פה ב100?
כי
ופה יש לך, נגיד, אז זה כאן, או שזה, או שהוא ירה כאן, או שהוא ירה כאן, מה זה
לא, זה
משנה?
לא ככה. זה לא ככה כאילו.
של B הוא לא אמור להיות ככה. אגב, זה פרואסון או מה?
לא יודעת. אנחנו יכולים פה טיפה לצלצל לפני כן, ואז אומרים ש-B ו-C הורים בהתחשב עם A הבא. ו-B רב בהסתברות של 0.5.
לא, זה ספייק יחסית, זה עוד יותר קל. אז את אומרת, זה או ככה, נגיד, היו לך פה על 5 כאלה, זה היה לך או פה, או פה, או פה, מה זה משנה, נכון? בסוף יש לך ספייק אחד מכאן, ויש ספייק אחד מכאן.
אבל אני יודעת כמה זמן עבר, זה יכול להיות באותם.
אז את אומרת, בחמישית מהמקרים זה היה ככה, בחמישית מהמקרים ככה. לא, במצב כזה, אז יש לך ישירות את הספקים האלה.
אני ממציאה את המחלקים האלה.
כן, אז תראי, אין לי עכשיו לשלוט, לא ישבתי וחשבתי על זה המון, אבל מה שאני רוצה